Let us talk about this problem. We are given a doubly linked list. We need to delete head node or first node of this doubly linked list. Let us see this example. We have three nodes 10, 20, 30 and head is here at the first node. So once you delete the head node, your doubly linked list will become 20, 30. Let us see this example. We delete this head node and our doubly linked list becomes empty. We represent an empty linked list as null. This is how we represent in C++. This is how we represent in Java. If your input doubly linked list is empty itself, then there is nothing to delete. So we need not to change anything. We need to keep the head as null. Now please pause this video and write down a function that takes head of a doubly linked list as argument, deletes the node at head and returns new head of the doubly linked list. Let us now talk about the implementation. In doubly linked list, previous of first node is always null and next of last node is also always null. Now if you wish to delete the head node, there can be multiple cases. The first corner case is if the given linked list is empty. In this case, we simply return the null. The second corner case is if there is only single node. If there is single node, then you delete that node and you return null. In Java, there is automatic garbage collection. So we do not need to explicitly deallocate memory for any node. We simply return null. In C++, we delete the head node and we return null. Now let's talk about the cases when we have two or more nodes. And here is an example case. Here we have three nodes. This is our initial head. Previous of head is null. And next of last node is null. Although we don't care about the last node here because we are only here to delete the first node of the doubly linked list. So what we want is, we want to delete this node. We want to set the previous of this node as null. We also want to mark this node as head node. So this should be our new head. To do all this, we simply need to do head equal to heads next. And once head comes to this node, we need to change heads previous to null. That's all we need to do. That's all we have written in Java. We do head equal to head next, we do head previous equal to null, and we return head. Now talking about C++ implementation, in C++ we need to ensure that we deallocate memory for the previous head as well. So to deallocate the memory, we return the previous head or the input head in a temp variable. Then we do the same steps as we did in Java. Head equal to head next, head previous equal to null. Then we delete the head, right? Previous head that we stored in the temp variable. We deallocate the memory and we return the new head. So we did head equal to head next. So head was moved from here to here, right? Then we did head previous equal to null. So this was removed, right, from here and its previous became null. And after that, if we are programming in C++, we deallocated memory for this node. Otherwise, we simply return head. If we are programming in Java, we need to simply return head. So this is implementation of removing head node of our doubly linked list. Time complexity of this implementation is θ1 because we are doing constant number of operations.